Good morning, good afternoon, and maybe good evening to all of you wherever you are. We are pleased to welcome so many participants to address an important issue today, the feed and its processing. Indeed, we were concerned mainly on the feed cost through the feed composition for many years. Price of raw materials and ingredients have increased over the last years, justifying the search for alternative feedstuff, cheaper feedstuff. Availability of feedstuff is also a concern for optimization of the feed, but we often forget to consider the impact of feed processing. Indeed, a couple of years ago, I would say before COVID crisis and so on, we were roughly counting on $10 to $12 or euro per ton of feed to completely process the feed. But the recent and still ongoing conflict between Russia and Ukraine has really changed the figure of the energy cost. And now the processing can reach from $20 to $30 per ton of feed through the skyrocketing of the energy cost nowadays. We do not know how long this situation will last, but we thought it was important to address this issue of high energy cost in our industry, as we are consuming a lot of energy for grinding, mixing, pelleting, eventually thermal treatment of the feed. So it's very important to consider this aspect of energy and also the availability of the energy source. And not only talking about the price, but talking about the availability in the coming weeks. Earlier this year, during the World Poultry Congress webinars, two events concerned feed and feed processing earlier this year. Those webinars can be accessed again through the WPC 2022 website, and lots of questions addressed how to reduce the energy cost at the composition level, but also at the processing level. And one of the important questions was why not to go backwards from the pellet to go back to mash feeds, and would that save energy, and how can we manage that? So on behalf of my colleagues, and especially Margot Le Collinet and Florian Bardot, I'm pleased to welcome around the table today, first François Lucas, project manager at Tech Aliment, the French research and innovation for feed technology. He will address the management of energy in the feed mill and the possibilities to save energy during the feed processing. Welcome, François.
Hello, Pierre-Henri.
I'm also pleased to invite Oliver Holmes around the table, Environment and Compliance Manager at Avara Foods from UK. He will speak about the energy management system in his feed mills through the ISO 50001 certification. Welcome, Oliver.
Hello, Pierre-André.
And I'm pleased to invite a good friend, Birger Svies, professor at Norwegian University of Life Science. He will develop the link between the feed form and the performance and the nutrition of the animal, and with the question, should we go back to mash feeds to save energy, and what would be the impact? Welcome, Birger.
Thank you.
And now I will not forget my colleague Marc Perel, our Global Products Application Manager at Adiceo, who will address the question of the additives application from the additive supplier. Should we consider the benefits of changing the form of the additive, liquid towards powder, and how to deal with liquid additives when we are considering mash feeds? So welcome to all of you. And I would like to remind all the participants that it's time to ask questions whenever you want. You just drop your questions on the platform, and we will try to answer to all the questions at the end. And if we are not, if we have not enough time to answer to the questions, you will receive the response on the website. So to set up the frame, we have asked François Lucas to introduce the topic of managing energy in feed processing. Briefly, François works with Tech Aliment, a feed technology structure, developing all aspects of feed technology in the industry. François has indeed more than 30 years of experience in optimizing energy performance in animal feed manufacturing plants, working on reduction of energy consumption, carrying out energy audits, drafting good practice guides, training people, making education, and that is an important part we have to talk about later on. So I'm really pleased to welcome François. So François, the floor is yours.
So I'm going to speak about some key energy indicators, some energy consumption breakdown, some influence factors, and some methods to improve energy consumption in the feed mills. But before, I'm going to present Techaliment and the energy situation. So Techaliment is a French technical center of the animal nutrition. There are 100 members, come from 10 different countries. Techaliment gathers different actors like the producers of compound feed and feed additives, the feed supplier and automaticians. Techaliment works on different subjects like food safety, biosecurity, security of equipment and people safety like dust explosion, sustainability, and energy performance and industrial performance like process optimization. So, in current energy situation, feed mills face an urgent challenge, like you say, Pierre-André, in reducing energy consumption due to the cost of electricity and natural gas. Furthermore, for sustainability purposes, feed companies are interested in reducing their carbon footprint. So in 2021, in France, energy costs amount 20 to 30% of feed manufacturing costs. It's around 2 to 4 euro per ton. But with the energy crisis, the energy cost could be multiplied by 3 at 5 or more. So consequently, the energy cost could be represented around 50% of manufacturing cost in 2023, around 50 euro per ton. As a reminder, in France, the raw materials represent around 75 to 80% of production cost. So, on this energy context, Techaliment supports the feed mill's energy, like you said, Pierre-André, by focusing on 3 areas. The first one corresponds to support, to training, and to awareness on different actors of energy in feed mills. The piloting operators are specially targeted. The second area gathers the action to measure, to monitor, and to analyze the energy performances. And the last actions allow to identify and implement the good energy practices. So to this end, Techaliment realizes audits and energy diagnostics of feed mill manufacturing and realize diagnostics on the utilities too. Okay. So it's essential to install energy meters in the feed mill plant. These energy meters allow to know energy consumption distribution between the different energy users and to define the energy performance indicators. So energy meters allow to understand energy using in the feed mill plants. Okay. Generally, electricity meters are more commonly used than gas meters or steam meters. In fact, the electricity meters are less expensive than gas meters or steam meters. So this slide shows energy indicators commonly used. The first indicators present on this slide is mainly used to monitor energy performance of feed mill manufacturing. This indicator is calculated from the energy consumption divided by amount produced. Okay, but there is other indicators to the utilities, like for compressed air system, the indicators commonly used is the consumption divided by compressed air produced amount. And for steam production, the indicator commonly used is the thermal consumption divided by the steam produced amount. Okay? So these performance indicators must be calculated at regular time intervals. It's very important. For example, 1 time by day or 1 time by week. But sometimes some industrials calculate specific indicators consumption per each feed batch. So, as I said before, the energy meters installed allow to know the breakdown of energy consumption. There are 2 kinds of energy used in feed mills, power energy and thermal energy. On this slide, the first figure at your left, represents an average 60% of total energy consumption in the French feed mills. In addition, the thermal consumption represents on average 40% of total energy consumption. So, what about the power energy consumption? The motor power consumption represents around 90% at 95% of feed mills power consumption. Roughly 70% of feed mills power consumption is used by only 5% of motor installed in feed mills. These motors are hammer mill motors, press motor, hammer mills fan, cooler fans, and compressed air system. So it's very important to install energy meters to measure the power consumption of these motors and to calculate the specific consumption of these motors. Okay? So it's also important to measure expander power consumption, but in French there is no often power consumption expander. Sorry. So according to the second figure, the pelleting operation is the mainly user power consumption in French feed mills. The power consumption of pelleting operation represents around 50 at 60%. The grinding operation is the second user power consumption, around 50 at 25%. And the third user power consumption is the compressed air system, around 7%. Okay? So what about thermal energy consumption? In France, natural gas is mainly used to produce steam, but there is also propane and domestic fuel. The pelleting operation used approximately 90% of steam produced. So in conclusion, pelleting operation is the main user energy consumption in the feed mills. It's very important. This operation represents on average 70% of total feed mills energy consumption in France. So, in French, the feed mill specific energy consumption is between 30 at 90 kilowatt-hour per ton. Many factors explain the variability of specific energy consumption, like the raw material, the feed quality, like particle size, durability, and physical presentation. Okay, so this figure on this slide shows some example of specific energy consumption according to feed physical presentation. The specific energy consumption of coarse mash is approximately between 5 and 10 kilowatt-hour per ton. For feed mash used in pelleting operation, it's approximately 10 at 50 kilowatt-hour per ton. For pellets, 50 at 80 kilowatt-hour per ton. For crumbs, 80 at 120 kilowatt-hour per ton. So, in this current situation of energy crisis, it's essential to debate about the potential modifications of the feed physical presentation. If we want to talk about influence of mash particle size on hammer mills, Tecalima realized several studies about influencing factors on hammer mill performances. The target of one study was to model the hammer speed and the screen characteristic effects on the average particle size. On this slide, the figure shows the significant influence of average particle size on specific energy consumption of hammer mills. As an example, when average particle size increases until 600 micrometers to 1400 micrometers, the specific energy consumption decreases significantly, around 4 kilowatt per ton. But don't forget, the average particle size has also a significant influence on the hammer mill production throughput. So when the average particle size increases, the hammer mill production throughput increases too. So now I'm speaking about pelleting performance indicators. So as I said before, the pelleting operation is the main energy consumer in the feed mill plants. It's therefore important to have good indicators to monitor and analyze the energy performance of the pelleting process. For example, the die wear and the roller wear have a significant influence on the power consumption of the pelleting press. On this slide, the figures show an industrial example of monitoring specific power consumption of the pellet press. In this case, when the specific power consumption exceeds a threshold, the manufacturer changes the die of the pelleting press. For this example, the threshold is around 70 kilowatt-hour per ton. But there is also other energy consumption influencing factors like pelleting qualities, the pelleting throughput, and also the mash treatment temperature. So, this slide shows an example of the effect of the mash treatment temperature on the specific energy consumption of a pelleting process. On this example, when the mass treatment temperature increases, the specific thermal consumption increases, it's logic, but the specific power consumption decreases and the pellet press production throughput increases. Okay, don't forget that. It's important. There is a lot of different effects on this on the specific energy consumption of the pelleting process, like the average particle size, the composition of the feed, the characteristics of the die of the pellet press, the tip of the conditioner. So, however, the optimal way to conduct the pelleting process depends on the same time energy performance, productivity, and pellet qualities. We won't only talk about energy performance, but also industrial performance. I think it's a very important point. So, some manufacturers use lean management tools, such as the short interval management or visual participative management, to improve the industrial performance of pelleting process, but also to improve the performance of feed mills. So, I just want to speak about energy waste. I think it's important. And it's important to identify and reduce energy waste in feed mills. When we talk about energy waste, we often think of compressed air leaks. Technically, realize more than 30 compressed air system optimizations today. More often, compressed air leaks represent between 25 to 60% of feed mills' compressed air consumption. So it's necessary to hunt air leaks twice a year at minimum. Don't forget, compressed air is the most expensive energy in a feed mill. However, that's also different sources of energy waste in the manufacturing process. This slide shows an example of electrical measurement made with a power analyzer. The figure shows the power drawn by the motor of hammer mill in red color at the left, and the power drawn by motor hammer mill in the blue color at the right. Okay? So, for example, with this measurement, it's possible to measure the hammer mill runtime empty for the hammer mill and for the heat fan. Okay? And these production times correspond to energy waste. So, in conclusion, for this example, it's possible to study to use a variable speed drive on the hammer mill and its fan to save energy consumption. And the last subject I would like to speak, it's innovative and efficiency equipment. So, as I said before, pelleting press consume average between 35 and 45% of the power consumption of feed mills plants. Technically, as observed, there are very few pellet press motors in France were equipped with electronic variable speed drives. So, technically realize a private study for these members. The first objective was to study the influence of the press die speed variation on power consumption and pellet qualities. The second objective was to estimate the technical difficulties to implement the variable speed drive on the pellet press motor. So, in conclusion of this study shows that using electronic variable speed drive can significantly reduce the power consumption, in some cases between 10 and 20%. And in this case, the pellet quality remains good. However, some technical difficulties have been identified to develop these technologies. Okay? So, in conclusion, during this presentation, it was not possible to approach all the factors influencing the energy consumption in feed mills. However, Tech-Aliment's experience shows there are many levels for improve. There is energy management, physical presentation and qualities of feeds produced, management of manufacturing process, and efficient and innovative equipments.
Thank you, François, for this very comprehensive review. And I think it's important to consider the global throughput and economic output of the feed mill. We often consider the energy management and so on, but I think at the end, during the discussion, it's very important to address the complete economical consequences of the full process. So really, thank you, François, for this nice introduction. And I just remind to the audience that it's always time to ask a question, drop question on the platform, and we will answer to the question later on this morning. I'm now pleased to welcome Oliver Holmes, Environment and Compliance Manager from Avara Foods in UK. Oliver graduated from Liverpool University as biologist and ecologist, and that is quite interesting to see that you can end up in the feed technology by the biological background. Since then, he has acquired more than 25 years of experience in all aspects of environmental management and sustainability, obviously particularly concerned by climate change, by water, by waste and so on. He joined Cargill in 2011, responsible for environmental management across Cargill European operations. And since 2018, he has overseen Avara's environmental and compliance obligation across UK, and with a particular concern, obviously, with climate change adaptation and mitigation. He has been in charge of the implementation of the ISO 50001 certification. Oliver, the floor is yours to better illustrate the practical applications of managing energy in the feed mill and how certification might be an opportunity and not only a challenge.
Thank you very much. I skipped on a slide. So my brief story is about how we've used our environmental energy management system to firstly quantify, then map and trend and improve our energy performance. It is actually a framework that covers quite a lot of what François has already said. We've used a lot of these tools within this management system to realise these energy improvements across the board. So Avara was formed in 2018 through a merger with Cargill and Fessenda Foods. There are 3 feed mills. Tram in Hereford was from Cargill. Banbury and Westbury were from Fessenda Foods. In 2021, we milled 851,000 tonnes of both chicken and turkey feed. And in the same year, we used 68,500 megawatt hours of total energy consumption. That split in 2021 was 70-30. That's different to the figure that François gave, but a better granular analysis of our operations has shown that mix now that we've removed the non-intensive milling thermal energy to be more 60-40, erring towards 50-50. So much more like the French feed mills that you were talking about. Slide 2 really is a story of 2 graphs. The first one tells half story, the second one tells a full story. The first thing is the whole process has been a journey across 4 years, from the formation of Avara to where we are now. All of the mills were included within the scope of the certification 50,001 in 2019. And with the initial focus on the new management system and with implementation of the tools within, a lot of the low-hanging fruit were picked. So installation of inverters, variable speed drives, LED lighting, replacement of motors, looking at baseline loading, switching off equipment when it wasn't needed. These things that may appear to be obvious, but you wouldn't see them obvious unless you look at the numbers. Refits that coincided with the stage of the organisation, so the switching of diets between. The efficiency correspondingly increased from 76 kilowatt hours per tonne to 74 kilowatt hours per tonne mill across all of the mills. However, from 2020 to 2021, due to a number of factors, we saw that trend reversed. And this is seen in the disappointing divergence of points in that first graph. Post-pandemic disturbances, enforced shutdown of mills because of incidents, the switching of different diets between the 2 mills. The entire turkey diet took its energy burden from Westbury Mill to Tram, and energy efficiencies correspondingly diverged between those two mills. So as a consequence, and because it was the right time to do it, we refreshed the management system in the latter half of 2021. And we rewrote it from top to bottom and then relaunched it throughout the organisation from bottom to top. It brought externalities that the board of directors know and shareholders are quiescent about, and it tapped into the knowledge of the people who own those processes. We brought in those external drivers, the drive to net zero, science-based targets, TCFD in the UK, and the relaunch was revelatory, as can be seen in the second graph. Across the board, we've seen a complete turnaround in the energy efficiency across all three of the mills, from nearly 81 kilowatt hours per tonne to just over 76 kilowatt hours per tonne thus far in 2022. Crucially, this has been done without capital expenditure. This is your maintenance costs and your day-to-day running of a mill. When you have the framework there with the input from the people who know the process, what you talked about, Francois, is brought into the framework and it drives that energy efficiency. And we've seen that across the board. On that journey, we learn a lot of lessons. Of course we do. In the UK, at least, we have an ongoing situation with cost of energy increasing. The energy is commensurate with 50-50 between raw materials and energy costs in 2022 into 2023. Our costs are probably set to increase by 50% by the end of the year and into the first quarter of 2023. This slide really, although busy and not intended to be read, gives 3-4 ideas that really should be focused on. Even if you don't adopt the ISO 50001 management system, these are the key tools. Firstly, change your paradigm away from hard engineering solutions to process control. What is different? What does someone walk past and know is inefficient or is a waste or is something that they could do better, and tap into that knowledge? Secondly, and this is the first slide in the top left here, map your process. Numbers. Numbers will always help you, and it can be as complex or as simple as you choose to make it, and the framework within the management system allows you to do it. But if you get those numbers, it gives you the granularity of that process, allows you to drill down into your specific process, use your expertise to adopt best practices. Thirdly, assess what changes your operation from external and within. Bring the externalities. What static factors are changing? What variable factors are changing? Diets, cost, shift patterns, times of operation. Bring those in. That's captured in the second part of the second picture in the slide there. And fourth, and possibly the most important, put everything into an energy action plan, the EAP that I've put into a 3-letter acronym in that slide. If you quantify everything into an energy action plan, it gives you the stages, your potential costs, your potential savings, a cost-benefit analysis. It even allows you, if you assign a value to the numbers, to make a cost-benefit analysis for sub-metering to get that granular data, which comes back to that. More numbers help you do that. And then finally, use other tools. AnnexSL, the high-level structure of these management systems, perfectly aligns with ISO 14001, which is the wider environmental aspects, and also the new standard ISO 14090, which is your adaptation to climate change. It stops you reinventing the wheel, and it gives you multiple benefits across multiple areas of the organisation.
Thank you, Oliver. It's very interesting because you focus on numbers, and very often we consider the processing as a black box. We consider the numbers as a whole and so on. But it's important to look at details. And you say numbers. It's key for the future to see how we can save. And I think it's very important. So we will talk a bit later on about that. I'm sure that a lot of participants will want to know a bit more on the details of the cost of processing and so on. Now, I'm really pleased to introduce Professor Birger Vius from Faculty of Bioscience, Norwegian University of Life Science in Norway. He did his PhD in poultry nutrition in 1997, mainly focusing now on cereal fibers, on feed technology, digestive tract function, the interaction between feed form and nutrition and performance and so on. He's well known through lots of conferences and papers. He has been the president of the Norwegian branch for some time, also president of the European Federation of WPSA. He organized a very successful European Poultry Conference in 2014 in Stavanger, in Norway. So that was a very, very nice time. And I'm really pleased to welcome Birger around the table today with a question. MASH, is that an option? Birger, the floor is yours.
Well, I think what I will do here now is to actually take the bird's perspective. And when we consider changing the structure of the diet because we want to save energy, we have to ask, I think the most important question is, how would the bird react? And the bird's reaction is, to a large extent, a feed intake question of how this will affect feed intake. It's also a question of how it will affect gizzard function and so forth, but I will not talk too much about that. But the bird response is very important. And to start with the most extreme change in diet structure, which is actually going from pellet to mash first, I think that these two figures I'm showing on the slide here, they tell something very important. In layers, generally speaking, we don't need to pellet. We can actually have some benefits of not pelleting because this will allow the birds to use more time eating. But the big and complicated story is really about broiler chickens, because as the figure to the right shows, the broiler chicken will benefit from pelleting because pelleting facilitates feed intake. The broiler chicken simply doesn't have a sufficient motivation to eat long enough to be able to have the same feed intake with mash diets. So that's the challenge. Anyway, there are countries in the world that are actually using mash diet. Japan, Belgium used to do it. I'm not sure if they do it anymore. And I have heard that in Spain they use mash diets for broilers now and then. So obviously it is an alternative. And it would save a lot of energy, as we've already heard. Grinding and pelleting is 80% of the energy cost. So it's interesting to look into it in more detail. And I mean, this table here, I'm showing some of the many experiments that have been carried out where they've been looking at the difference between pellets and mash. First thing I want to say when we look at this particular slide is that it shows a very variable result. And we have to be careful. If we want to interpret these data, we have to know what was the quality of the pellet and what was the quality of the mash and how feeding management was carried out and whether this was done in a commercial setting or in small pens in an university setting, which would have a large influence on the results. So you can see here, I mean, if you look at some of those, for example, the Lippens experiment, you see that in some cases there has been no reduction in weight gain, but a slightly poorer feed per gain, so a less efficient feed utilization. But in other cases, you have a very dramatic reduction in feed intake, which is generally what you would expect. You would expect a somewhat reduced feed intake, even if you try to avoid that by having the right structure of the mash. And I think that the right structure of the mash, if you want to go for mash diets, this is key to succeeding. And I'm using this a very nice experiment that was carried out in the US with mash diets. And just to illustrate that point, you see here one diet, you see the particle distribution of the corn in one diet of the figure to the left, higher one, and a coarser one below. And if you look down at the table, you see that feed intake was much higher when you have a coarser structure. So the key to having a acceptable performance if you do mash diets is to grind more coarsely, have a coarse diet that will reduce the negative effect on feed intake. And this is exactly what some of these experiments have been looking into, and they are highlighted here with a bold text. And you see here that for both of these two experiments, you see that going from fine mash to coarse mash increased feed intake. But again, you see something very strange when it looks at weight gain, because in one of the experiments, this doesn't translate into an increased weight gain. So it's kind of strange. But it illustrates another important point, which is that when you go to mash diet, you will probably, in many cases, have more feed spillage. That's another challenge. It's a challenge that must be handled with the right feeding management, I think. But we actually, in Norway, we've been taking part in some experiments where we actually have been trying out mash diet in a commercial setting, in commercial farms. And you see some pictures of mash diets. You see they're very coarse. And generally speaking, when I try to conclude what we achieved in field trials, in commercial practice with mash diets, and you see the mash diets were very coarse, 20% particles were, only 20% were smaller than 1 millimeter, and around 50% of the particles were larger than 2 millimeter in the mash diets. And what we have to expect is feed per gain increase of up to 200 gram per kilo weight gain, and 150 gram lower weight gain up to 5 weeks. This is our experience. Surprisingly, no negative effect on weight variability, and actually a lower weight variability. And actually we also saw some beneficial effect in terms of mortality and rejection at the slaughterhouse. So there is some positive health effects. And of course, they used more time eating. And this takes me to the last point I'm having, because mash diet is an extreme solution to the energy cost. But in fact, the pellet quality is another potential thing we can look into. Can we decrease pellet quality? And we'll save a lot of energy by doing that without affecting performance. And I think, yes, I think we are making a too good pellet. But as this table again shows, I mean, if you go to a too poor pellet quality, you will have a reduced feed intake. You will actually have maybe even poorer performance than mash. So there's a limit to how far down you can go. And I mean, the point is that if you reduce pellet quality, you can do this by increasing the die diameter. As this figure shows, you can increase feeder rate. There's a lot of different ways to do that. And you see here in our Feed Technology Center at our university what savings were at those conditions. It's quite significant. And the question then is, if you go to 1,100 kilo per hour and a 5 millimeter die, is the pellet quality good enough so you don't negatively affect performance? And also a coarser grinding, which already have been mentioned, so I will not use a lot of time on that, but a coarser grinding would also potentially give a little bit poor pellet durability, but again would save a lot of energy and have other beneficial effects in broilers in particular. And there has been some experiments carried out. Actually, this is a master thesis from my university showing that at least based on this experiment, there is a tolerance for we don't need a perfect pellet. We can accept that pellets break apart. And here the negative effect came when the amount of fines in the pellet was exceeding 20%. And another one, and this is one that is often cited in the literature, for example, Abonnez-vous has used this to argue for that we need to pellet, and it is also showing something of the same. But be aware of that in these particular experiments, both of them, the definition of fines were very fine fines. In this case, for example, 20% fines were 20% particles smaller than 0.5 millimeter, which is really small. And again, it was carried out in a very few days at the start of the experiment. So, in fact, I think that we have to redo these experiments. We don't necessarily can trust these. Also, the breeds have changed. And to follow up on that, this is the last slide, and it really shows, I don't know if you can see, but it shows actually, we actually gathered, together with Abonnez-vous, who sponsored this, we gathered feed samples from broiler diets from many different countries, and we looked at the physical structure. And you see on the table to the right, you see the general quality of the pellets wasn't very good. But if you look at the figure to the left, you see the proportion of very small particles, for example, lower than 1 millimeter. And you realize European diets, they have almost nothing of the fines. So I think we can slow down, reduce pellet quality, and we will not have a negative effect on performance of broilers. How far we can go down is still an open question. Thank you very much.
Thank you very much, Birger. I think it's nice to address this question of mash versus pellets, and we should be more specific. What specific mash forms compared to what specific pellet forms? And as you can see, there is maybe some space between a very hard pellet, as you do in Turkey, for instance, and a very coarse mash we do for layers. So there is a large space in between. So thanks for this addressing, Birger. So now I would like to introduce my colleague Marc Perel to have the insight of a feed additive company. Marc graduated in 1994 as an engineer in grain industry and has almost 30 years of experience in feed and premix manufacturing process. He is global product application manager for Adisseo since 2014, starting with the European region. And his main driver today, I would be very simple, is just customer satisfaction in additive application in the feed mill or in the premix plants. So Marc, please, the floor is yours from the feed additive supplier.
Thank you, Pierre-André. Actually, I would like to start saying that Adisseo has not, let's say, a specific offer of additives on this topic. We are more based on nutritional additives rather on technological additives. However, we started to get very positive feedbacks from the field, from our customers' plants, and I'm going to detail that, taking the example of the methionine and the positive effects that we got year after year on the after switching from powder methionine to liquid methionine. Many customers found some savings, typically at the pellet mill. And I remember some trials conducted in Malaysia in 2015 showing savings in a range of 2 to 3%. So from this time, we really wanted to investigate this topic. So it will be the first part of my presentation. So in 2016, we conducted a first trial in the Tech facility in Nantes, where we compared the energy consumption at the pellet mill with diets, one with powder methionine and another one with liquid methionine. So in this first trial, I'm going to explain these results, but prior to explain and go into the details on the results, about the conditions. We used used a diet, let's call it the dry feed, and we started to compare on equimolar basis the two forms of methionine on a typical diet. If I remember well, it was a corn-based diet, and so what I love in Tech Aliment for such trial is that the conditions are very well controlled. The flow rate is controlled. The energy consumption is measured every second. So we are in very well controlled conditions. This is why it's very, and we can rely also on the results because we repeat the treatments. We measure the pellet quality by measuring the hardness, the PDI, and the fines rate. And it's not mentioned here, but for this trial and the next one, we measure the pellet quality, and it's important to say that the pellet quality for each couple of treatment remains equivalent. Because don't forget, this is a general message, and it has been mentioned a bit by Berger, but let's consider a triangle. Of course, we can consider the global energy consumption of a mill, but of course, you have to consider the productivity. This is why we use this ratio of kilowatt hour per ton. You have to consider the flow of the mill, the production. But do not forget also the quality, as mentioned by Berger. You can easily decrease or increase your efficiency, degrading the pellet quality. So that's obvious. So in this trial, it's important to mention that the pellet quality remains equivalent between the treatment. So having said that, if we focused on the first on the left bars on dry feed, I will explain what it means, but it's the raw diet. We could demonstrate comparing an equivalent level of methionine between powder and liquid. On this first set of trials, we found a reduction of the specific power consumption of 7%, namely, as we can see on the graph, something close to 1 kilowatt hour per ton in these conditions. Then we try to investigate, we try to highlight, also to understand the effect of the additive by increasing, by doubling and multiplying by 3 the quantity of liquid methionine. And you can see on the left graph that doubling the liquid methionine does not change the specific consumption, but then you have a significant decrease by increasing, by multiplying the level by 3. So there is an effect. Obviously, the liquid methionine is not the objective to put more and more liquid methionine to decrease, but that was to highlight and to try to understand. So that's the first series of in this trial. On the second series, we used the same diet, but we added 0.5% oil to see with a different context, with a different diet context, if we still find this. Let's say that in these conditions, we see no significant difference between the two diets at 0.2 content of powder methionine and 0.23% of liquid methionine. But then when you increase the quantity of liquid methionine, again, you see the decrease. But at an equivalent level, in these conditions, there is no difference. Then we wanted to go further, and in the third set of trial, we increased again the level of oil, of added oil, and here we refound this effect, this positive effect of the liquid methionine with a reduction of 4%, which is again significant, versus the powder methionine. And again, when we increase by 2 the liquid methionine level, we see no significant decrease. But when you multiply it by 3, again, you see a significant decrease. So here we can demonstrate a positive side effect of the liquid methionine. So not in all contexts, but you can see in some contexts. So at least you gain, or if, let's say, you are not lucky, there is no difference between the two forms. So later on, we conducted the second. This is also an additional set of trials in 2016, where we could see that we could save from 3% when the feed is dry, and up to 4% different. This is on the last part of the graph. We could save up to 4% when we have free oil and added water. So we had 3% oil plus 1% water. So in this case, we could save up to 4%. I will not go into too much details. I will go to the more recent trial that we set with Techaliment to continue investigating the effect of the diet. So actually we had a control, which is the first one on the left. So fortunately, that's the formula A, which is wheat based. Wheat based means, if my memory is good, 40% wheat, 40% wheat, 20% corn, and 30% soybean meal, and the rest is minerals and premix. The second one is mainly is corn based. Then we use the wheat based to make the formula C, adding 1% oil. The formula D is the formula A plus more oil, 3%, and the last diet, formula E, is the formula D plus 1% water. So 3% oil plus 1% water. So we saw different effects. So on the first one, on the wheat-based diet, we could see, thanks to the liquid methionine, a decrease of the net power consumption at the pellet mill of 8%. Then when we switch to a corn-based diet, here we see no significant difference. So you can see the effect of the diet, and typically the source of cereal would make a difference. If we come back to the wheat-based diet, adding 1% oil, again we show a significant difference here, up to 13% reduction between liquid and powder methionines. On formula D, when we add more oil, again we remain with this advantage of the liquid with a reduction of 12%. But lastly, when we take the formula D and we add 1% water here, and I cannot explain why. This is still the mystery of this trial, but this is to show you the truth. I will not remove the ones I don't want to show, to be transparent. On formula E, adding water, there is no significant difference. So as you can see, the effect of the formula is really key, and sometimes you have, let's say, positive results or significant different results, and sometimes you have no difference. So it's a case by case, and I would say let's go in the feed mill and make trials with your own formulas. So that's the first topic. I would like to address a second topic, which is about the different forms of still on the methionine, the different forms, powder and liquid. So it started with a study conducted by Techaliment. I will come back to this lately. Actually, Techaliment in 1999 conducted a study in several feed mills in France, and on the mixing performance of the feed mills. And globally, the median CV, it was conducted with the micro tracer, powder tracer. The median CV was close to 5%, which is good. But among all these feed mills, 13 were producing, or the trials were made on layer mash, so coarse mash. And here, Techaliment found a median CV of 14%. Which is not so surprising, as powder additives premix minerals it's more difficult to make an homogeneous mix, and such diet are more prone to demixing. So I wanted to investigate this topic by conducting a trial in 2019 in a French commercial mill, a big one, something like 300,000 tons per year. So I just compared with two different batches of 6 tons the distribution of the additive powder methionine and liquid methionine in the different fractions of the diet. And as you can see on the top graph, you see the powder methionine, which is logical, is mainly concentrated in the fine fraction, let's say below 500 microns, whereas the liquid methionine, as it sticks to the particle, is more homogeneously spread, which can be also benefic, let's say, also for the intake and the performances. This is mainly what I wanted to share.
Thank you, Mark, for these presentations. And I think you address a question which is compromise. Never forget, in fact, it's always a compromise between the output, the quality of the pellets, of the feed, and so on. So compromise, we often say nutrition is a compromise. We have to make always a choice, but in feed technology too, so it's important. So now it's time to interact with the participants. So I will move now to the session on question and answers. So let's look at the first question. Or maybe the first questions, can you put that? Yes. As pelleting seems to be the main contributor of feed processing cost, and obviously you all mentioned 50 to 60% or even more, what are the options to optimize that pelleting step? Maybe who wants? Oliver, maybe.
I think we've covered it, haven't we? You map your process, you get good granular data, you analyse the data, you optimise your process, you have someone to own it, you get the numbers, you match it together, and then you do compare, like you do with the feed, with the diets. You trial different things, and you'll hit that sweet spot.
So it's important to start with the correct analysis first of the situation.
Always, yeah.
I mean, if it's possible, you must have electrical meters, but also steam meters to have the twice energy in the same time. It's very important. Okay, I think it's and you must also don't forget to train the conductor operator at a regular time. Yeah. It's a very, very important thing. And the new operator, you must train the new operator, because sometimes there is a new operator in the field.
Yes, and we often forget to put some time on those people and so on. I think it's important you say meters, so to get data and so on, and to monitor that and educate people, in fact, how to deal with these measurements and so on. I think it's important. Maybe you want to add something on this pellet part.
Because I think also that and I totally agree with what you're saying, that we need to get more information out of the feed mill, and if we continuously monitor and restore data from, for example, the pelleting process, we should also link that to physical quality measurements. I know many feed mills have automatic durability testers, that are actually testing the flow. And when we can link those two, we can actually look at the cost, and we can actually get the value for the cost of, for example, increasing durability so and so much. And then when we combine that with biological data, we can actually tell when it's cost effective to increase durability.
Combining with biological data, you say feed intake is a driver. Why not to use maybe a short feed intake measurement, to see how the chicken or the turkey is reacting to this diet change?
Yeah,
form change.
Yes, I agree. But there is adaptation. For example, when you change the diet, let's say if you only look at the effect in a few days after you change the diet, you may miss the long-term adaptation. So in broilers, at least, I think that it would be better to have a complete picture from a whole period of raising broilers, because again
the classical comments that what is waste at the beginning or what is missed at the beginning is never captured after in broilers. So some people say if you lose half a day or day of consumption at the beginning, you will never recover at the end. What do you think about that?
Yeah, I mean, yes, this is also a very important question, that if the structure changes very dramatically, you may have a negative effect in the few days that the birds need to adapt. So that is also something that needs to be taken into consideration. But these are another layer of complication to this big question of structure. I mean, you also need to take into consideration. So if you have, let's say if you have pellets as a starter diet and you then change to mash, maybe it would be better to start with crumbles when you want to go to mash, because that will be less of a change of structure. So these are also things that we need to think about. So it is, as usual, multifactorial.
So we would talk about education of the chickens, during the process.
Yeah, exactly.
Thank you, Birger. Maybe next question. So, moving to mash feeds, again, should we revise the thermal treatment to apply to partly compensate for the loss of the energy put during the pelleting, often used for hygienization of the feeds and so on? What is your comments on that? Who wants to answer?
Well, I mean, in countries where you do not, when heat treating is not required by law, or required by the broiler producer, I would definitely say that the main big advantage is when you don't need to heat treat the diet, because then you can take away that significant cost that we heard about. Maybe 40, 50, 60% of the cost of the pelleting is the conditioning. So if you still have the condition, the savings are not as large. And then you have a challenge with getting that moisture out of the mash diets afterwards, so which will usually require investments in a new cooler system that can handle mash diets. So in my opinion, mash diets are particularly interesting when heat treatment is not required. And in many countries, it isn't.
Yeah. You want to add something?
I absolutely agree with Birger. So as you said, the first negative effect of treating this mash is the energy consumption. As you mentioned also, then we need to remove this steam to cool and dry the mash. So it's an additional operation. So much more easy to make a crude mash and send it to the finished feed silo. Also, the negative potential effect is the effect on thermosensitive additives. You may lose some enzymes, vitamins, part of it. The positive one, as you mentioned, also is for the treatment against microbes, typically Salmonella, and also maybe a last point, which is the positive effect of thermal treatment on flowability. This has been demonstrated that treating the mash significantly increases the flowability of the mash.
So it's important when we consider mash and pellet to consider it's not exactly the same way to proceed. So you need to adapt to make a mash competing with a pellet. And you mentioned also, all of you, I would say, you mentioned that maybe pellet should not be very, very nicely hard pellets like we do for turkey and so on. So maybe a possibility also to evaluate a little bit, I would say, on that.
Exactly, and I think that another topic, maybe we'll touch upon it later, but it's the fact that when you have mash diets, if you switch to mash diets, maybe you should do something with the composition of the diet, as the first table I showed, the higher density the diet is, the lower is the negative effect of going from pellet to mash. So I think, and this is something we probably will discuss later, but the question of adding oil to mash diets becomes particularly interesting in a mash diet situation, both from a nutrient concentration perspective, but also I think, but I don't know, I think that some oil would potentially reduce the negative effects on feed intake because it binds the fines. But then, of course, as we have to then be careful with not having too much oil, so we have a sticky diet that is not flowing so easily, and so finding that balance is, of course,
again,
something we need
to find.
We need to look into, right?
Okay.
But I could say that in the mash diets we have tried in Norway, we have added up to 5% oil and we used it in commercial situations. So it seems that 5-6% oil added in mash diets is, we didn't observe any problems in the feeders and the tanks at the farms when we did it.
Another question for the energy guys. Do we have data about extrusion versus pelleting energy consumption?
I think the extrusion is the consumption of the extrusion is more. How do you say? I'm sorry, there is more consumption for extrusion than pelleting energy, than pelleting process.
And we talk about doubling the energy consumption, or just margin.
Maybe I would say for electricity, I would say we could be close to up to 100 kilowatt hour per ton. Yes, but what we have to mention, first of all, as we said, we are not talking about the same. We can compare ton to ton, but an extruded feed is not a pelleted feed. Yeah. But having said that, you are much higher with of course with extrusion on both sides with thermal energy, since you heat the mash at 100 or more than 100 degrees, 110. 20, so you put more steam, more energy there, and more also mechanical energy, so more power consumption. So I would say, and again, we cannot compare because it's not the same product. You can double, triple the energy consumption with extruded feed, but again, it's not the same product.
Any comment on that? What is the utilization of extrusion today in Europe?
Basically, extrusion is for aqua feed, for pet food, and more very seldomly, I would not call it extrusion, but more expanded feed. I know that in Northern Europe it can be used for swine feed or even poultry feed, but I have I have no data on this especially. It is more seldom, but it's more expander rather than extruder. Because of this cost also, there is a gain in terms of, I guess, digestibility, the starch gelatinization and so on, but there are drawbacks also. I was speaking about additives, again, some thermosensitive additives, if they go through the extruder, some will disappear.
An interesting question on the platform now. What about, and it's a question of education of the chickens. What about using pellets in some phase, like the starting growing phase, and then move into mash? Could we benefit from this system, not lowering so much the growth rate, and but have a reduction of the energy cost?
Well, yes, this is things we need to think about. I mean, when are we using mash? Which periods? And again, we don't have the data, I think, because there hasn't been that much study on these delicate details in the use of mash. But if I was going to give a more or less qualified guess, I would say that I would not start with mash diets from day zero, but I would start with a crumble. And then I would actually, then I would actually consider to use mash maybe from go from starter to mash. Perhaps then use mash a period, and then potentially switch to pellet again. I mean, that would be a possibility. Because the reason why I think so is that as the broiler, I'm talking broilers now, as the broilers grow, the competition for space becomes harder because they are taking more space and the feeders are the same. That's one thing. Secondly, the willingness of the broilers to stand up and eat is reduced. They are heavy, they are too lazy to stand up for a long time. So therefore, I think at the end of the grow-out period, mash diets will potentially have a more negative effect. And then, in addition, all this talk about gut health, saying that some indications of a beneficial effect on gut health by slowing down the growth rate a little bit between 14 to 21 days of age may be beneficial, because there has been some experiment, not with mash diets, but with other types of experiment where you have reduced feed intake in that period, and it has been shown that they're able to compensate by eating more later.
Yeah.
So that would be my guess of what would be a good mash feeding system if you don't want to use it all the time.
So we need to address this question of transition and so on to be sure that
Yes.
it's efficient and so on.
Yes, exactly.
You want to
I
add?
would like a very simple comment, or maybe a question for you, Birger. You mentioned, and which is very common, feeding the birds at the beginning with crumbles. Just an idea, why not, and this is done by some manufacturers, why not making, instead of crumbles, which are very consuming, as explained by François, why not going with short pellets? You set the knives close to the die, so instead of making crumbles that sometimes you need to sieve and you lose productivity, maybe an option could be to go to short pellets. Can be an idea.
Absolutely. I'm
Maybe
actually working on this right
Yeah.
now with a commercial feed company, and we don't really have the results yet. But definitely, I think that it would be very interesting, particularly looking at your data, François, on the energy cost of crumbling. I was very shocked to see the difference in pellet and crumbling on the energy cost side. I think it is possible to imagine, as you say, using knives to produce crumbles instead of using a crumbler.
Definitely.
And if you put the knife close enough, 2 millimeters from the die, you produce, I don't know if I would call it crumbles, I don't know if I would call it short pellets, but at least something that is something in between pellet and mash, which is exactly what the crumbling process does. Another thing is that the pattern of the rolls that you use. I know I've heard from several now, by changing the pattern, you can actually use the rolls to produce short pellets. So that's another option that I wasn't aware of, but I now am.
I think it's important to really reconsider. And when you talk about coarse and fine mash, for instance, versus pellets, but we should also consider a coarse and versus a fine grinding before the pelleting, and maybe the quality of the pellet. Because I remember some years ago we were used to introduce whole grains in the feed, even through pelleting. So what could be the saving in that case, using whole wheat grain, for instance, or whole corn particles, to reduce the grinding cost, and in fact to stimulate the gizzard and so on?
Exactly.
You want to go, Birger, please?
Yeah.
Well, I'm talking too much. I already warned you.
No, that's fine.
But the point is that's my second point, is to look at, if mash is an extreme solution, which I don't. I think is interesting. I'm not against it, but the other one is a more low-hanging fruit to consider the changes in the pelleting process to save energy and do that without a negative effect on performance. And the pellet diameter. If you increase the pellet diameter, we tend to use 3 to 4 millimeter pellets in Europe. In the US, it's very common with close to 5 millimeter pellets for broilers, and in Brazil also. And when I realized that, and we've been carrying out some experiments, and we realized that by going from 3 to 5, and we have done it, there is no negative effect. And no negative effect in broilers from 14 days of age.
And the energy consumption at the pellet mill is significantly different.
It's reduced.
Definitely.
And besides, the coarse, the grinding effect of the pellet mill is less when you use a large diameter. So you actually get more coarse structure in the pellets, what I call a microstructure, which is good for the gut development. So it's a win-win situation.
Yeah, but now you are challenging the feed
sorry.
additive supplier, because in fact you have maybe a less quality pellet and so on, so you have fine particles and the big pellets and so on. How do you make a good spraying of additives on that type of mixture? I would say.
You mean the post-pelleting application?
For instance, yes.
But whatever the quality of the pellets or crumbles or whatever, you will spray the additives in post-pelleting, typically enzyme, the same way. There is no no impact. But I think the challenge is more if we totally switch from pellets to mash. Some manufacturers, they spray, as I mentioned, the enzymes in post-pelleting. So tomorrow, how to use enzymes if you are not using this post-pelleting, as there is no more pelleting. So either if you continue to use the liquid, you can spray it in the mixer. So you need an equipment to spray the enzyme in the mixer. You can even switch back to powder, because in general liquid is used when there is a harsh treatment. So if there is no more treatment, you can go back to powder. And sometimes, but it's a case by case today, sometimes you can send, especially if the mash is heat treated, sometimes you can go through the cooler to cool and dry the mash, and go to the fat coater or enzymer, where you can add also the enzymes. So again, it's a case by case, but why not switching back to powder? That's an option.
So, in fact, we've received a question addressing that, you know, when you move back on the mash feeds, how do you use your spraying system and so on. So I think it's interesting, because when we change the feed aspects, the feed form and so on, we are going to be challenged on incorporations of anything, you know, that has to be dealt with. So I think it's important.
In some way, I think that when you use mash dyes, liquid additions in general are a more interesting option than dry powder. I don't know about, but the reason why I'm saying that is that usually these additives, enzymes, and so forth, are very fine particles, right? So you risk that they are separated from the diet. If you use liquid ones, you spray them on, they're attached to the particles. Very interesting what you saw with the liquid methionine there, that seems to be attaching more to large particles. But a good mash should contain a lot of large particles. So then an additional effect of liquid additions in mash dyes is, I think, the fact that it binds these powders to larger agglomerates. And this is good up to a point where it becomes sticky and it doesn't flow. I mean, So
when we go back to the feed mill, and I love, Oliver, when you mention data, numbers, mapping the energy management in the feed mill requires implication of the workers, of the operators. How do you motivate these guys to be really key on collecting the data, measuring, you know, not only automatic meters, but they have to be involved. How do you do that?
I think you use what you've got. I've never met an engineer who will work happily with an inefficient process. They don't do it. Likewise, I've never met an engineer who will not suggest an improvement in an efficiency of a process. So it's used, involve them. Interestingly, referring back to the standard, all of the ISO standards I've mentioned, well, 14,001 and 50,001, have a particular clause where the organisation has to get the opinion, the information and the input from an individual or an organisation who works on behalf of you to make an improvement in energy. And this is something that you cannot avoid doing. If you subscribe to 50,001 and you want to be certified to the management system, you have to demonstrate to an external body that you're doing that. Now, there's a number of ways you can do it. You know, first of all, you employ people who know what they're doing, but you also throw open suggestions, and it can be something like a QR code. In fact, we use it at Avara. We have posters where any employee can walk past with a camera phone, use a QR code, and it sends an email to the person who is responsible for the energy management at that facility. You will filter out some noise, but you will get a lot of suggestions by people who know the process. Likewise, from employees who might not be involved in the process, you can take it all the way up to building in requirements for energy improvements into service level agreements. So if you subcontract somebody to look after your boilers or your chilling systems. We don't in field, but in the factories as well, we have a lot of chilling. You write it into their service level agreement, so it's part of that dynamic agreement between you and your supplier. Tell us what we can do better. It builds a relationship. Everyone wins. And I think that's really key. And then motivating people.
Yeah, education and training.
Exactly. It's what Francois said.
Yeah.
It's education and recording how you do educate people. I think you cannot lose from doing that.
Yeah. So I think it's important that you have more efforts to do on education, training, helping operators to think about the importance of collecting data, or really having good data to after optimize the energy management and so on.
Yes, it's an important challenge for us and for females.
Thank you very much. So I would like to thank our speakers today for this different view on the fact that we should take into account the feed processing to save, obviously, energy, because today we are challenged by the cost of energy and we have some opportunity to save. It doesn't mean to move from pellet to mash, but at least to look at all the process and look at maybe step by step or incremental improvement we can have in the different steps. Obviously, we are not going to replace one step by another, but at least we can reduce maybe 5-10% in each step, and then you save at the end quite a significant amount of energy and of euro or dollar per ton of feed. So I think it's important. So it's time to thank everybody, thank the audience for the questions, and do not forget that you can still ask some questions, and we will transfer the question to the speakers to give some answers, and you will find that on the platform. And I will be also happy to say that you can watch the replay of the webinar today on the FeedChannel platform. So maybe you can show the address on the screen, and I would like also to warmly thank our ladies, Florian and Margot, for their initiative to address this energy issue with the objective to identify opportunities to save energy during the feed processing. And I would say I should not conclude without mentioning the organization of other webinars by Tech Aliment organization. And this afternoon, for instance, at 2 p.m., they will organize a webinar on grinding process innovation and operating model challenges. So don't forget, you can rewatch the webinar, this morning webinar on www.feedchannel.online, and don't forget that there is other webinars on the topics, because I think it's an important issue. And as we say, nutrition is a compromise, but offering the feed to the animal is also a compromise. So thanks again to everybody around the table, and thanks to the audience for your participation. See you for the next webinars.
Thank you.
Bye-bye.